Assignment 4.3.1 Data Collection Techniques. Within data collection techniques, there are research designs. There are 6 types, such as experimental, correlation, longitudinal, case study, cross-sectional, comparative studies. Longitudinal, case study, cross-sectional, comparative studies. These are types of descriptive studies. There are also research sources, and this is primary and secondary data, as well as classification of data, which involves nominal data, ordinal data, interval and ratio data, which is continuous, and discrete data. Also plans the outcome and the type of research they're researching. Case study. Case study, according to simple psychology, can be defined as an in-depth investigation of a single person, group, event, or community. This means that it's an in-depth investigation and it shows development through time of an individual or a group. This is often in real-life content and takes a longer period of time for this to happen to show the development of the studies. An example linking to gymnastics of a case study is collecting measures from an individual under 16 years. This could be developed by investigating the measures and recording and seeing the development over a long period of time. So this is a case study investigation because it takes a long time to be able to see these changes and be able to see the development of their measurements, either an individual, and it is focusing on an individual, which is one of the factors of a case study. Studies is a conclusion drawn at the end to show the findings of which is rich data, which means that they can draw the conclusion to see if after a long period of time to see what has happened through the development. Also, the results from the test can improve their lifestyles. These gymnasts can change their lifestyles from the result, and this could improve their gymnastics and make them become a better gymnast. It also gives no prejudice. The disadvantages are that it can be biased. This is because it only has the view and the opinion of the researcher, shows what the researcher decides. Also, it takes a long time to collect the data because this case studies have to happen over a long period of time to be able to get the quality data, and the data cannot be generalized to the general public and a wider variety of people. Cross-sectional studies. Cross-sectional studies is a descriptive observational study that involves measuring different variables in the population of interest at a single point in time. It's also known as a snapshot. So use a range of participants with different backgrounds, ages, genders from all over the population. Cross-sectional studies are observational studies that involve recording information without manipulating the environment. An example linking to gymnastics of a cross-sectional study is measuring the heights at which female gymnasts can jump at different age groups. So they will be measured at the age of under 16 age group, 18, 20 and 22. This is a cross-sectional study because they're being measured in specific groups, not being measured over a period of time. The advantages of this is quick and easy to amass data. This is meaning that the comparing and the test does not take long to conduct. This is because the results can be collected there and then. It's also can compare different variables and contain multiple variables at the time of the data snapshot, and this can also lead to multiple outcomes that can be researched at once. And most of these experiments are low cost, which is an advantage because you don't want an experiment to be too much. The disadvantages can be it cannot determine why something happens and what the effect is, and this cannot be proven. Also, it cannot be used to analyse behaviour over a period of time because it happens there and then, and it can be biased. This is because of the strong feelings involved. longitudinal studies. This can be defined as an observational study that employs continuous or repeated measures to follow particular individuals over a period of time. For this, you can compare the same age groups at different times. For example, age. So every 10 years, you would compare the changes and see how they've developed as a group. This longitudinal studies is observational, meaning that there's the same variables that are the same over a period of time. Also, the researcher doesn't influence the participants, so that means that they shows the development and can show the change in a group of individuals and groups. If you did a test to see if glucose improved the gymnastics flexibility range of movement over 5 years and measured the group each year with their flexibility, every 5 years with their flexibility increase. This is a longitudinal study because it happens over the same. It happens to the same individual over the same amount of years, so every 5 years. The advantages of longitudinal case studies is due to the studies being over a long period of time, it can identify sequences and patterns within a study and draw a richer conclusion because it happens at the same amount of time each year. It's easier to draw a conclusion. It also allows the researcher to look at changes over time, which allows a pattern to be shown. There are observational methods to collect data because it's much easier to collect and compare because you can see the results a lot more quicker. The disadvantage is they can take a long period of time to be able to draw a conclusion because it happens every so many years. They require large sample sizes to better test the hypothesis and get richer results. And some of the participants could drop out at any time, which could either make the experiment longer or to make it harder to find results. Comparative data. Comparative data can be defined as studies which compare two or more things of research methodology of collecting data that can compare more than one thing. It involves comparison and contrast between two or more types of data. This means that you can compare one type of data to another type of data. So it could be your data to someone else's data who's done the same experiment as you to see if your results are similar or different. An example of comparative data is measuring and comparing the vertical jump heights of young gymnasts aged 12 and 16. So this is a comparative data test because you will measure the jumps of 12-year-olds and measure the jumps of 16-year-olds to see the similarities and differences and compare them to be able to get better results and draw the conclusion. And it's because you're comparing more than one group. The advantages of comparative data is by comparing the results against normative data, it allows you to understand the top standards, which means that when you compare your data that you've got against someone else's, you can see if the way that you've conducted the experiment and got your results is as good as someone else's. However, this could also be a disadvantage because you both could have done the experiment wrong or the test wrong, but still have similar results. And you might not know how the other researcher did their results, and conducted their experiment, so they could get different results. So it's not good to always compare against others. The disadvantage is it could be biased, and the researcher could change their results because they want to show that their research and their findings is the best they could possibly do, so they might manipulate the results to show that theirs is the best. Correlation. Correlation can be defined as measuring the extent to which two variables are related. So most of the time correlation is plotted on the graph, and it can either give different types of correlation. It is also the statistical analysis of data to determine the pre-existing relationship and examines the relationship of two or more between two or more non-manipulated variables. correlation. An example of correlation in gymnastics is the effect of PNF stretching on female gymnasts when performing floor. So, in relation to correlation in the graph, you could say as the amount of stretching increases, the performance of the gymnast increases. So if this was on a graph, this would be positive correlation because you'd have the stretching along the bottom and the performance at the top, and they're two different variables. So you might be able to draw a conclusion as if you increase your stretching, your performance will increase. The advantages is that it determines whether there's a line between the variables. So if you didn't get all your results and there's a clear correlation, you can tell where the rest of the results will roughly be because there'll be a line of best fit to show us either positive, negative, or scatter correlation. Another advantage is it also collects more data, so you could think if they stretched even more, you could roughly guess how much their performance will increase, and the results are more applicable to everyday life. So this is in an everyday life for gymnasts. They would have to stretch to see if their performance improves, and it's one of the things I have to do every day, and it's something that's not silly. A disadvantage is only shows the relationship between two variables, doesn't draw a conclusion, and it doesn't show which variable influences the other. This means that impacts the other one to be able to get the results, and it doesn't always show the results that you want because more than one variable or the two variables you have on the graph can influence your conclusion. For example, other things other than stretching, such as conditioning, could also improve their performance when competing because their overall fitness will be better. So what uses correlation studies and type of correlation? So there's validity correlation, and so validity is does it measure what it's meant to measure? So you have current validity between a new measure and an established measure, which links to being used for comparing new BIA methods with hydrogen cytometry, which is underwater weighing, which can link to the gold standard of measuring body fat to make it valid. You also have reliability correlation, which is how reliable your results are. So you have retest reliability, which is are the measurements consistent, which uses multiple tests, uses the BIA equipment 5 times to be able to compare the results to get the correlation on a graph. And you have inter-rater reliability, which is observing the content, which involves different researchers. Correlation is measured by the direction of which the points are plotted on the graph. So you have a positive correlation, which goes up, and negative correlation, which goes down. You also have scattered correlation, where the points are all over the place. So negative correlation is when the points increase as one variable increases, the other variable increases. Negative correlation is where one variable decreases, the other variable decreases, and the line goes the other way. Scattered correlation is where the points are all over the point and it's random results measured on a continuum from -1 to all the way to +1. So the closer to -1, the more closer the points are to the line, which means that the negative correlation is really strong. The closer to 1, the more the points are closer to the line of best fit, which shows that the R value of the positive correlation is very strong, whereas a scattered R value would be 0 because all the points are all over the place. However, if lines in a positive and negative correlation are still in the direction of the line of best fit, but some are scattered over the place, you might have an R value of 0.7 because the correlation is not as strong.